Hello, Stat 200, and welcome to Lesson 10. This week, you'll be learning about one-way analysis of variance, typically referred to as ANOVA. Section 8.1 of your textbook covers one-way ANOVA. In addition to this content, we'll also be covering Tukey's post hoc test, which is not covered in the book. There are only two key topics this week. First, the one-way analysis of variance, and then pairwise comparisons, specifically the Tukey method. A one-way ANOVA compares the means of three or more independent groups. You can think of this as an extension of the independent means t-test. When we learned about hypothesis testing, the issues of multiple tests were discussed. If we want to compare more than two groups, we should not just run multiple independent means tests because the actual alpha level overall would be greater than 0.05. Instead, we run an ANOVA, which looks at the differences across all of the groups at once and keeps the actual alpha level to 0.05. When you're conducting an ANOVA, the sampling distribution can be approximated using the F distribution. As always, this is dependent on a few assumptions. In order to approximate the sampling distribution with an F distribution, the samples should be approximately normally distributed, and the sample standard deviations should be similar. ANOVAs will always be right-tailed tests. So when you're constructing the F distribution to find your p-value, it will always be right-tailed. Like the t distribution, the F distribution has degrees of freedom. There are actually two different types of degrees of freedom for an F distribution. Between groups, which is just based on the number of groups, and within groups, which is based on the sample size along with the number of groups. The test statistic is an F-test statistic, also known as the F ratio. It is a measure of variation between groups over variation within groups. Here we have plots comparing the distributions of heights of students who say they prefer beer, water, or wine. Between groups variation, which was the numerator of the F-test statistic, is a measure of how different the sample means are. Within groups variation then, which is the denominator of the F-test statistic, is a measure of the variation within each group. ANOVA is sometimes referred to as an omnibus test because it gives us information about all of the groups at once. These are our hypotheses. The null hypothesis for a one-way ANOVA is always going to be that all of the population means are equal. The alternative hypothesis is that the population means are not all equal. This is what an ANOVA source table looks like from Minitab Express. Different softwares will use different terms. This example is using the data from the previous slide that is comparing students who prefer beer, water, and wine in terms of their heights. Here, the beverage row is our between groups variation. So this is a measure of how different the beer, water, and wine groups are. Error is our within groups variation. This is how different the students within each group are. You can see that there is only one F value and one P value. This particular ANOVA is statistically significant because our p-value is very low. As before, the standard alpha level is 0.05. Since our p-value is less than 0.05, we reject the null hypothesis. This means that the overall ANOVA model is statistically significant. The means of the three groups are not all equal. But this does not tell us which groups are different from one another. We will need to do a follow-up test, known as a post hoc test, to determine which pairs of means are different. Your textbook does not cover any specific pairwise comparisons. The online notes will introduce you to Tukey's honestly significant differences tests. There are many different post hoc tests. Tukey's test is popular because it makes all possible pairwise comparisons. Minitab Express will give you two different pieces of output with all of the possible pairwise comparisons using the Tukey method. This is the first table. Here, any groups that do not share a grouping letter are significantly different. Beer is only in group A, and water and wine are only in group B. Because beer and water are not in the same grouping, the beer and water groups are significantly different. Beer and wine do not share a grouping, so the beer and wine groups are also significantly different. Water and wine are both in group B, so water and wine are not significantly different. This is the second table that you'll get in Minitab Express. This is actually the one that I prefer to use. It computes the t-test statistic for every possible pair, and it gives you an adjusted p-value. So these p-values are adjusted to take into account that there are 3 pairwise comparisons being conducted simultaneously. We can look at these p-values, and because they're already adjusted for multiple tests, any of the p-values that are less than 0.05 signify a statistically significant difference. This concludes the Lesson 10 overview video. If you have any questions this week, please post them to the Lesson 10 discussion board in Canvas.